In this video, we're going to talk about how to use the specific trig ratios sine, cosine, and tangent to solve for missing sides of right triangles. So hopefully this is just a little bit of recall. But remember, sine of an angle is the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. And tangent is opposite over adjacent. And this is all specific to the ratio that you want to apply to a specific angle. So in this example at the bottom, we're going to let side X have a length of 24, side Y have a length of 10, and side Z have a length of 26. And let's start by talking about the angle theta. So talking about this angle here. The first side length that I always identify is the hypotenuse, which will always just be the side length across from our right angle. So in this case, this side length of 26 is going to be the hypotenuse. Then I like to identify the opposite side. The opposite side is the side if we take our angle and shoot across and hit. That's the side length we would call the opposite side. So in this case, 10 is the opposite. And then whichever side length is left that makes that angle up with the hypotenuse, that will be our adjacent. So in this case, 24 is the adjacent. And again, this is all specific to that theta angle. So if I said, okay, then what is cosine of theta? It's the adjacent over hypotenuse. So in this case, 24 over 26. And since those are both even numbers, we can divide them both by 2. This will actually reduce to 12 over 13. Sine of theta is the opposite side over the hypotenuse. We said the opposite side is 10 and the hypotenuse is 26. Again, that can reduce. 10 over 26 would reduce to 5 over 13. Tangent of theta is the opposite side over the adjacent. The opposite side is 10, and the adjacent side is 24. Again, those are both even. We can divide those by 2. This would reduce to 5 over 12. So I'm going to clear that drawing out, those side lengths out, because now we're going to move on to that omega angle and see how the ratios change. Okay, so those side lengths, they still don't change. They're still their original values. But now I'm going to use this omega angle. So no matter which angle we're referring to, this hypotenuse side, that will stay the same. It's always the side across from our 90-degree angle. Now what's different is if I take that angle and I shoot across, the opposite side now is 24. 24 is the opposite. And the only side length left, the one that makes that angle up with the hypotenuse, is the side length of 10. So now this side length is the adjacent. So if I wanted to know cosine of that omega angle, adjacent over hypotenuse would be 10 over 26. And again, we can reduce that to 5 over 13. The sine of omega would be 24 over 26, opposite over hypotenuse. That'll reduce to 12 over 13. And tangent of that angle, opposite over adjacent, would be 24 over 10. And that'll reduce to 12 over 5. So now we're actually going to use those ratios to solve for side lengths. So I'm going to show you that for whichever angle you choose, it's not going to change the result as long as you set the ratios up the way that they are designed. So in this triangle, we're given this angle beta up here in the top, that this is 52 degrees. And we're told side length CB is 7. And we want to find all of the missing sides and angles. Well, we know that angle B in the bottom there is 90 degrees. So let's find this angle alpha first. We know there's 180 degrees in the triangle. So let's take away the 90 degrees and the 52 degrees that we already have. And we'll get that this angle alpha must be 38 degrees. So we've got all the angles in the triangle covered now. So what I'm going to show you next is that using either one of those angles, we can find all of the missing sides. So let's use the angle 52 degrees first. If I'm going to use that angle of 52 degrees, we know AC, no matter what, whichever angle we were going to choose, AC is going to be the hypotenuse. If we're choosing 52 degrees, side length AB is the opposite, and side length CB is the adjacent. Alright, so let's solve this right triangle using just that angle of 52 degrees. So if I wanted to find side length AB using 52 degrees, then I would say tangent of 52 equals opposite is side AB and adjacent is side length 7. And what we have there is just basically a proportion. So we're going to say tangent of 52. Okay, let's put that over 1 and use cross multiplying. 1 times AB is AB equals 7 times tangent of 52. And again, that's just using cross multiplying. So now we're going to use our graphing calculator to compute 7 times tangent of 52. It's important to make sure that your calculator is in degree mode. There are videos at the bottom of the Blackboard page that show you how to do these computations on the TI-84 graphing calculator. But making sure your calculator is in degree mode, you would just do 7 times tangent of 52 into 4 decimal places. It'll tell you side length AB is 8.9596. And again, that's just rounding to 4 decimal places. So we found side AB. This is 8.9596. And now let's find side length AC. For side length AC, that is the hypotenuse. And for 52 degrees, 7 is the adjacent. So adjacent and hypotenuse, I'm going to use cosine. Cosine of 52 degrees equals 7 over side length AC. And again here, let's put this over 1. If we cross multiply, we're going to get AC times cosine of 52 equals 1 times 7 is 7. To solve for side AC, we're going to divide each side by cosine of 52. So here we get AC equals 7 over cosine of 52. And again, using the graphing calculator, now we're going to do 7 divided by cosine of 52. Into 4 decimal places, we'll get 11.3699. So notice how we used 52 degrees to find those two missing side lengths. We're now going to look at how you could have used the actual angle measure of 38 degrees to find those side lengths. So I'm going to clear this out, except for the angle alpha, and we're going to go through and find those same lengths using 38 degrees. Alright, so let's use the 38 degree mark instead, or the angle alpha of 38 degrees. So this is still the hypotenuse. But now the sides are going to change. Now if I shoot across from 38 degrees, this side length CB, or a length of 7, this is now the opposite. And this side length here, AB, this is now the adjacent. Alright, so let's start by finding AB first. So in this case, for 38 degrees, 7's the opposite and AB's the adjacent. So tangent of 38 equals 7 over side length AB. Putting tangent of 38 over 1 and cross multiplying, AB times tangent of 38 equals 1 times 7 is 7. We divide by tangent of 38. Which will give us side length AB equals 7 over tangent of 38. And if we put that in our graphing calculator, again we'll get 8.9596. That's the same length that we got using 52, but in the opposite direction. So let's now find side length AC. We know 7 is the opposite. AC is the hypotenuse, so here we're going to use sine. Sine of 38 equals 7 over AC. Putting that over 1 and cross multiplying, AC times sine of 38 equals 7. AC equals 7 over sine of 38 then. That'll come out to 11.3699, which is what we got going the other direction as well.